Myself Khushi Banerjee, and the subject name is Electronic Devices. Today we will study about the biasing of PN junction. Now, PN junction biased, it is a two-terminal device. It can be biased in three ways. First is the unbiased PN junction, in which there is no externally applied battery connected to PN junction. Now, the other two are the when we connect a battery to PN junction, it can be biased in two ways, that is the forward biasing and the reverse biasing. Now, what is forward biasing mode? When the positive terminal is connected to the P region and the negative terminal is connected to the N region, it is known as forward biasing. While in case of reverse biasing, when the negative terminal it is connected to P region and positive terminal it is connected to N region, it is known as the reverse biasing. Now in this diagram we can see a PN junction which is being forward biased because the P-type semiconductor of PN junction diode it is connected to the positive of battery. In P region the majority carrier at the hole which is repelled by the positive of battery, due to which the holes then gains the energy to cross the depletion region or the potential barrier and move from P region to N region. Similarly, the electrons, which are the majority carrier in N-type, is repelled by the negative of battery and are able to cross the potential barrier and the depletion region width formed at the junction and move from N-type to P-type of PN junction diode. So the direction of movement of hole it is from P to N and direction of movement of electron is from N to P. Due to the movement of carrier across the depletion region and across the potential barrier, the width of depletion region decreases as well as the potential barrier also decreases, due to which a current starts flowing across the PN junction diode. Now what is the direction of the current flowing? It is same to that of the movement of hole and opposite to that of movement of electron. As the hole moves from P to N, so the direction of movement of current it is also from P to N in PN junction diode. So for a forward bias PN junction diode, the current flows from P to N direction. Now what happens when a PN junction diode it is being reverse biased? In this we can see that is P is connected to the negative of battery and N is connected to the positive of battery. So the majority carrier hole which are present in the P-type semiconductor will be attracted by the negative of battery and they start moving away from the PN junction. Similarly, the electrons which are negatively charged particle, they move away from the junction moving to the positive of the battery. As the electron and hole moves away from the PN junction diode, that is the junction, so there is no electron and hole crossing the depletion region width, due to which the width of depletion region becomes wide and the potential barrier also increases. As there is no electron and hole flowing across the junction, so the current due to majority carrier it is very less or zero when a PN junction diode is being reverse biased. Now there are some minority carrier also in P-type semiconductor. Here they are shown with the orange dot, while in the N-type also there are some minority carrier holes which are shown with the white dot. Now these minority carrier, under the influence of the externally connected battery, they move across the junction, that is from P to N and N to P. So a very less amount of current starts flowing across the PN junction diode due to the minority carrier. Now what is the difference between forward bias and reverse bias? In case of forward bias, the positive terminal of battery is connected to P-type and negative terminal is connected to N-type. While in case of reverse bias, the positive terminal of battery it is connected to N-type and negative terminal it is connected to the P-type semiconductor. In case of forward bias, the depletion region width is very narrow because electron and hole starts flowing across the PN junction. While in case of reverse bias, the depletion width is thick. In case of PN junction, it offers a very low resistance because we know that as we increase the bias forward bias, the value of current also increases, while in case of reverse bias, it offers a very high resistance. So an ideal diode has zero resistance when it is being forward biased, while an ideal diode have infinite resistance when it is reversed biased. Thank you all.